Hi, today I am going to talk about the soil CO2 flux at Vulcano during 2021. The diffuse degassing of CO2 is of utmost importance for volcano surveillance. Gas composition and geophysical parameters give important information on the state of the volcanic activity, but CO2 flux measures the gas output that is correlated with magma degassing. Furthermore, the soil CO2 emissions causes gas hazard for people living in the nearby of the surface manifestation of the volcanic activity. Gas hazard need to be managed by civil protection agencies based on reliable data and continuous updating. My name is Roberto and I am researcher at the INGV in Palermo. This is the outline of this presentation. In the first point, I will discuss about the motivation of the study. Since late summer 2021, Vulcano showed sign of arrest by fumarole temperature increase, changes in the gas composition that increased the gas hazard at Vulcano. The central part of the presentation focuses on the experimental method I did use for soil gas investigation at Vulcano, which consisted in the determination of the carbon isotope composition and the soil CO2 flux measurements. The changes in the soil CO2 flux, the carbon isotope composition, and the estimation of the volcanic gas output will be discussed in the last point. After that, I will list the main points of my work. A very important aspect of estimating volcanic CO2 emissions is that a large amount of CO2 is released due to the rise of magma in the volcanic plumbing system. CO2 is less abundant than water and is also less soluble in magmas. Therefore, the volcanic CO2 forms at high depth in the earth interior. Another important thing for volcano surveillance are the changes in volcanic CO2 emissions that can help in tracking the transitions toward a high level of volcanic activity. Volcanic CO2 rises through fracture and faults of a volcano and causes measurable changes in groundwater, in emissions by central conduits, and in soil CO2 emissions. In summary, I would have to say that the amount and the origin of the soil CO2 are key variables to correlate the change in the diffuse degassing with changes in volcanic activity. The study aims to investigate the soil CO2 flux and the evolution of the volcanic CO2 emissions to obtain information on the causes of the recent crisis. Since the end of the last eruption, Vulcano showed fumarolic sulfuric activities and soil CO2 emissions. Several crises punctuated the volcanic degassing. Crises consist in change in temperature, gas output, and composition of the volcanic gases. In the study, we estimated the deep originated gas emissions by coupling the soil CO2 flux and the carbon isotope composition measurements. The soil gases were investigated using a sampling grid deployed at the base of the volcanic cone on the western side of the island. The CO2 flux was measured in agreement with the dynamic concentration method. To measure the CO2 flux with this method, a stainless steel probe is inserted in the soil and is open to the soil gases and the atmosphere. An IR spectrometer measures the CO2 concentration in the mixture of soil gases and air. By pumping the gases at constant rate, the CO2 concentration achieves dynamic stability after a few minutes, and the CO2 concentration is dependent from the soil CO2 flux through the empirical equation here. The data of CO2 flux have been processed through the probability plot proposed by Sinclair, and the tree population model represents the best data classification. The average CO2 flux in the anomalous subset is 2 orders of magnitude greater than the average values of the background. Two anomalous degassing zones were found at Faraglione and Palizzi. The isotopic measurements were performed on site by using a laser-based spectrophotometer. Some technical solutions were developed in the laboratory and applied in the field to measure the isotope composition in the full range of the soil CO2 concentration. During survey, the less certain depleted values have revealed the geologic origin of the CO2 and were measured in the anomalous degassing zones. The most C13 depleted values revealed the biologic origin of the CO2, and these values have been measured in the large part of the targeted zones. We developed a three-component mixing model where the CO2 source are the volcanic CO2, the biogenic CO2, and the air-CO2. The three-component mixing model allowed partitioning the soil CO2 flux between biogenic and volcanic origin. I'll show here the evolution of the soil CO2 emissions at Vulcano during late summer to autumn 2021. The results of the soil gas survey indicate that two anomalous degassing zones occur at Faraglione and Palizzi respectively. These zones are sensitive to the change in volcanic degassing, whereas the soil CO2 flux is in the range of the soil respiration in the large part of Vulcano Porto. In October, the position of the anomalous degassing zones did not change, but significant increase in soil CO2 flux occurred at Piano delle Baracche and new mofete formed at Camping Sicilia. Soil CO2 emissions increased at Camping Sicilia in November, and further strong increase of soil CO2 flux occurred in late November throughout the Vulcano Porto area. In conclusion, notable changes occurred in the soil CO2 flux during September to November 2021. Move on the evolution of the carbon isotope composition of the soil CO2. During September, the volcanic isotopic signature of carbon in CO2 was observed at Faraglione and Palizzi. At that time, the average delta C13 was minus 15 per mil, while throughout the Vulcano Porto area, the CO2 was from soil respiration. In October 2021, the CO2 at Faraglione shows the signature of the volcanic gases at Vulcano. Soil CO2 exhibited a large proportion of the volcanic CO2 at Piano delle Baracche and Camping Sicilia, and the average delta C13 increases to 2 units. This trend continued in November. In conclusion, during September to November 2021, the CO2 showed less C13 depleted values throughout the Vulcano Porto zone. These results show that volcanic CO2 replaced biologic CO2 in the soils at Vulcano Porto. The three components isotopic mass balance model shown here allows partitioning point to point the soil CO2 between biologic and volcanic sources. Besides the theoretical air, the biogenic end member has been selected as the soil gases having the highest CO2 content and the most C13 depleted carbon. The volcanic end member has been selected as the poorly C13 depleted pure CO2. The soil CO2 partitioning allows evaluation of the amount of volcanic CO2 and biologic CO2. During 2021, soil CO2 was less diluted by air and less C13 depleted. The increase of soil CO2 concentration, the increase in soil CO2 flux, and the increase in delta C13 supports the input of volcanic CO2 at Vulcano. Let me to move on the question concerning the quantification of the diffuse degassing during 2021. The amount of volcanic CO2 emitted by soil changed from almost 100 tons per day during September to more than 1000 tons per day in November. The CO2 produced by soil respiration was in the range of the seasonal variability at Vulcano. An interpolation of the results of the four surveys provide more than 120,000 tons of volcanic CO2 emitted by soil during September to November. Since soil CO2 accounts for almost 10% of the volcanic emission, and a rough estimation of the volcanic CO2 emitted by the crater zones provide almost 389,000 tons, the integration of the volcanic CO2 emitted at Vulcano was more than 500,000 tons of CO2. This is an unprecedented, sudden, and wide change in the volcanic degassing at Vulcano. A comparison with dataset collected during 2015-2018 shows that previous changes in soil degassing accounted for almost 30% of the volcanic CO2 flux variability. Furthermore, during the 2015-2018, the volcanic to biogenic CO2 mass ratio ranged from 1 to 5, while in 2021 this parameter achieved 17. Based on the estimation of the amount of CO2 emitted at Vulcano, we speculated on the causes of the degassing crisis that occurred during 2021. Vulcano has an articulated plumbing system that consists of several reservoirs connected at the Mo boundary layer with the basaltic oceanitic magma body. By taking into account the almost 500,000 tons of CO2 emitted during September to November 2021, the average magma composition inferred by previous studies, and the CO2 solubility in magma, we infer that an instability of the magma body at the Mo boundary layer caused the crisis at Vulcano. By taking into account the same quantities of CO2 and the solubility of CO2 in brines, the exsolution from an hydrothermal reservoir would involve an improbable large volume of the hydrothermal system at Vulcano. Let me to move on the conclusion of this presentation. Soil gas surveys were performed at Vulcano from September to November 2021, and CO2 emissions showed significant changes. CO2 flux increased several orders of magnitude. The carbon isotope composition showed that the volcanic CO2 substituted the biologic CO2 in the soil gases at Vulcano Porto. Soil CO2 showed delta C13 values similar to the CO2 emitted by fumarole at La Fossa Con. High CO2 emissions are hazardous for people living in the nearby of the surface manifestation of the volcanic activity. Therefore, the access to Piano delle Baracche and Camping Sicilia was prevented by Italian DPC authorities. Continuous monitoring of CO2 flux from the soils and CO2 concentration in the air are suitable actions for mitigating gas hazard and volcanic risk. The coupled monitoring of soil CO2 flux and stable isotopes help to track change in volcanic activity. In particular, the crisis at Vulcano during 2021 we infer that can be correlated with instability of a magmatic body lying at the Mo boundary depth. Thank you for attention. Bye bye.